Did you say you're all jacked up on lasagna? All right. Okay, guys. By definition, the upper bound theorem. I started. There's too much giggling going on, guys. Cut it back. All right. On your previous one, I don't have a copy of it right in front of me. Let's stop talking, please. Emil, Victoria. Let's focus. All right. I'm going to borrow off one of your guys's. The upper bound theorem states that suppose C is a positive real number. You got a positive real number. And P of X is divided by X minus C. Because if C is a real number, then X minus C would be the root, right? So in other words, if we tried 2 inside of this, then that we got that from X minus 2. This is just saying C is a number, we would have gotten it from X minus C. Okay? So if C is a positive real number, and P of X, some polynomial, is divided by X minus C, the resulting quotient, big if, the resulting quotient and remainder have no change in sign, then P of X has no real zero greater than C. Thus, C is an upper bound of the zeros of P of X. Lower bound theorem, you're going to use f of negative x instead of f of x. It's the same thing. So first thing we're going to do is find an integral, which means an integer. Okay. Find an integral upper bound and an integral lower bound to the function f of x equals 3x cubed. F of x equals 3x cubed. All right. So we're going to try to find an upper bound. So I kind of do a 2-column thing going on. Upper bound. You're good. You don't need it until the end of the period, right? There's no reason to have it now.
Oh, yeah. I just wanted to make sure, because I kind of feel bad. That's my favorite.
I drank it. All right. So when you do an upper bound, it's actually better to test a little high and then work your way down. So here, like just logically thinking, our Q is what? 1. Our P is 3. Our Q is 1, our P is 3, right? So really, I mean, logically speaking, we know our zeros are, if there are rational zeros, they are somewhere like around their 1, 1/3, things like that. But we can pick a number, so I'm going to pick something that I know is obviously going to work, and you're going to see how this works. So I'm going to pick 3 as an upper bound. I'm going to choose, so this is a little bit random, and I'm picking a number. What I'm going to say I'm considering a little high. Maybe you pick 5, right? Don't pick 10, but, you know, pick something. So 3. I'm going to say maybe that's an upper bound. That's a guess when you guys go to look at it. Don't think that I have some logical reason for picking 3. I mean, for me, it's an educated guess. I don't have any gaps, right? 3, 2, 1, nope. Huh? Oh, -1, thank you. All right, 3 times 3. 9 minus 2. Positive. 3 times 7. 21 plus 5. 26 times 3. 78. And 78 minus 1. Okay. Do you see that there is no change in sign for the entire quotient all the way to the remainder? All of those are positive. Right? That means do not pick a number bigger than 3. 3 is an upper bound out of my solutions for zeros. If I try a number and there's no change in sign, that number is the biggest is bigger than my biggest zero.
So if the first number started off as a negative and they were all negative, would that still be
Still the same thing.
Okay.
Correct. But what this means is, well, could there have been a smaller number that would have worked? And there is. Now, do we want to drop down to 2 or do we want to try 1? 1. So right here,
So it can't be 0 either?
can. Yeah. No change in sign, no 0 greater than 3. So I'm going to try 1. Oh, yeah, I'm using the same one. I'm not using the depressed because that didn't have a remainder. Yeah. Huh? There's no 0 greater than 3. There is no 0 greater than 3.
So what if we picked a number and it gave us a 0? That's when we would use the depressed polynomial.
Right, because then we're trying to find the zeros. That means yeah. So all my answers are still positive when I used 1. So there is no number, no 0 greater than 1. I should keep on trying lower, technically speaking. But at this point, I'm going to stop. I'm going to call 1 my upper bound. Now 0 can be an upper bound. 0 could be. But I can tell right off the bat, guys, if I use 0 right here, I drop the 3 and I'd put in right here what?
Oh,
0. And 0 plus negative 2? Negative. So I'd have 3, then a negative. 0 is not going to work. But that is going to tie into our next concept. Right. So more than likely 1/3 is going to be it's something less than 1. Our 0 is something less than 1, if all of them. If not one of them, all of them. Our lower bound. So now I'm going to write down what f of negative x is. F of negative x, and only my odd ones change, negative 3x cubed minus 2x squared minus 5x minus 1. Okay. Right. So this kind of answers that question. Now, I want to go high and then once again drop down numbers. However, we could be pointed out that that one alternated, so there's a chance something happens. Does this one change signs at all? No, and since I'm adding, as long as it's a positive, any positive, this is just knowing your numbers. Any positive number here, I mean, first of all, that's going to be a -3. A positive times a negative makes a negative plus a negative, more negative. Positive times a negative, negative, more negative. Positive times a negative, negative. Like, if I put any positive number here, this is all going to remain negative. So,
You see the confusion in my face? Like, I figured it out, but, like, I contacted you.
and yeah, and then I continued the eye contact as I motioned. Yeah. And then you dawned, and then I moved away.
Yeah.
Don't worry, I know my facial expressions.
No, it's a dumb question.
Did you write your tests?
No.
Are you going to soon?
It won't be till this weekend. I probably will not this week. Yeah,
If I did bad stuff, it's so bad.
good.
Can I help during lunch?
Not quizzes. Not quizzes. So, all right. But let's, so I know 1's going to work. I know 1 is going to work. So let's try something less than 1. 0. Oh, I could try no, negative 1 won't work though. Okay. 0. So 0 is a lower bound. By the way, I should have put the sentence here, technically speaking. 3, not 3, down here. So 1 is an upper bound of f of x. So here, 0 is a lower bound of f of x. It's still, so we have to be careful, and let me talk about that after people are done writing. Yeah.
Since it says f of negative x, why is it negative 2 positive 2?
Because it's squared, so even if I make it negative x, it'll just turn it back into a positive, so it won't change the sign. I started class literally saying I missed you guys because I was a tick the last day and a half.
Yeah. Sir doesn't listen.
I know. But it's okay because I don't mind repeating.
And I don't listen either.
Tired, Victoria? Yeah, she thought you guys were fine. The only comment my wife was texting me while she subbed for you, which she shouldn't have done, is the fact that somebody asked the question, "Is it bigger than a bread box?" And I mean, she literally put down the question. She was like, "Your kids, oh my, OMG, LLL, is it bigger than a bread box? Wait, what's a bread box? Wait, you put bread in a box." Like she was quoting.
What's a bread box like, actually?
So
Okay, it's a specialized plastic box that has a lid.
it doesn't have to be. It doesn't have to be plastic. They're usually wood. They usually are wood. So in Sada, bread boxes are primarily an Eastern kitchen item. So you do see them here if you want to have like a fancier house. They really serve no purpose in the West. In more humid areas, a bread box protects your bread from the humidity because that will it'll make your bread go bad faster. So right. So if you put it in the bread box, the bread box protects the bread somewhat from the humidity.
Can you show us a picture?
Yeah, Mr. Versailles.
Please, Mr. B. You've been talking about bread boxes for too long not to pull a picture. Okay, I just want to see it. Is there anything wrong with being curious? I think so. Oh, that's so cute.
Oh, I've seen those. Yeah.
Like they have some.
Okay. So yes. Anyhow,
Why would you say is it bigger than a bread box? That's stupid.
because you're just narrowing down size of the object. So getting back to this, guys. Well, that becomes difficult then. It's bigger than a bread box. Are you talking volume or are you talking about a singular dimension? Wait. Okay, guys. Well, they'd have to be in the room to see it. So, just means somebody's trying. But it's okay. I could just go back to my PC. I don't have to. They could keep trying. Whatever. All right. And I don't know what that's going to look like on the screen. So really quick, guys, what if it wasn't 0? That's the important part. Because of the fact that we did use f of negative x, we did not use f of x when we were doing the lower bound. We did f of negative x. So let's say this wasn't 0, because 0 doesn't help us make any much sense of it. If this was 3, then our lower bound would be negative 3. Even if we put a positive 3 in here, it's the opposite sign for our lower bound. We use f of negative x, but we use the opposite sign of whatever's in our divisor box when we put it in our lower bound, okay?
Say it one more time.
Yeah, say it one more time.
Sure. So when we're doing lower bound, we're using f of negative x. We're still going to be putting positive numbers going all the way to 0 here, right? So when we come down to what's the lower bound, we do the opposite sign of whatever's in that. So
if it was 1, I would say negative.
correct. Negative 1 is the lower bound.
Okay.
Yes, Nathan?
So with this one, if you put any positive in there, wouldn't it just like, wouldn't it still work then?
Any positive would have worked, well, if 1's a lower bound, well, then obviously 2's a lower bound, because if I'm saying nothing goes past 1, it would be dumb for somebody to say, well, does anything go past 2? No, it didn't make it past 1. How could it have even got to 2?
So with this, you're looking for like you look at this, you can go before it starts. The lowest
Right.
maximum.
Yeah.
Wait,
Eh.
so
Lowest maximum.
Anyhow, Victoria,
if it's negative, it's the lower bound?
if I'm doing f of negative x, that's when I'm testing the lower bounds. F of negative x, I'm testing the lower bounds. Aiden?
So that applies for negatives too, right? If it was negative 3, it'd be 3.
Yep.
So it only applies for the lower bound.
Huh?
It only applies. Does it only apply to the lower bound?
The opposite sign rule I'm talking about only applies to the lower bound. The upper bound, you take whatever number's in the box. Lower bound, you do f of negative x, and you take the opposite. So let's do a non-numerical example really quick. Okay? So I've got some. Okay, Nathan. Victoria, I've got some polynomial. Okay. Whatever it is. All right. So I'm going to test. I always do these upper bounds, lower bounds side by side. Okay. So my upper bound, I'm going to try some number, right? And I've got my coefficients, right? And let's say this is a positive number, right? And I get positive, positive, positive across the way. Then whatever this number is my upper bound. Let's say it's 4, right? That means since when I plugged in 4, all of these were positive, that means 4 is an upper bound of f of x, okay? Now let's say on my lower bound, I'm going to do, first of all, I've got to do f of negative x. So I'm going to take this and only my odd powers change, right? So I get some new polynomial, okay? And then I try a number over here. And let's say it's 3, right? And I've got my coefficients of this one, okay? And let's say that these all end up being positive also, okay? The sign didn't change. So on the lower bound, since I'm using f of negative x, then negative 3 is a lower bound. So on this one, I keep the sign at whatever it is. This one, I change it.
Okay.
Okay? Lucas?
So for the lower bound, you would want to start at a higher number also, right?
Yes. Start at higher numbers and work your way down.
So like just an example, like you would start at 6, if 6 didn't work, you go to 5 and then 4. And then
Even if 6 does work, go to 5, go to 4.
because it could be lower still.
It could be lower still.
Okay, cool.
It could be lower still. Anthony?
So you have to find the lowest one,
Yes.
and that's the correct
And
answer.
then
Yeah.
you also flip this
These 5 right here, you guys need to stop communicating while I'm teaching because it makes me not want to answer your questions later. Okay? Anthony?
So, like, for it to be correct, you have to find the lowest one.
Yes. And you can dip into the negatives.
and then it just becomes a positive.
On this one, it would.
Just for that one.
In this one, it wouldn't. Yeah, you can dip into the negatives on either of them. But if you dip into the negatives here, it becomes a positive number. You could. You could.
So say like that one, like say that was a negative upper bound, more than likely that's going to be a negative. But
Right. Well, your lower bound's always going to be a smaller number, but you got to be careful with the way. I mean, how much can your logic follow it? If 4 worked here as an upper bound, then negative 4 is not going to work here because that's just going to be the same answer as here. Which I'm not going to go over that one again because that's too complicated of an example for people to follow in their head.
So does it really matter what you do as your bottom numbers? If it's like positive or negative?
No, it doesn't matter what the number are. It just matters what sign they are.
Well, that's what I mean. Like, if the signs were like negative and positive, you still switch.
No, yeah. If you picked wrong, like I don't have one written here. We'll check it out on the next one. If the sign changes, if I had that, 4 is not an upper bound. I got to try a different number. They have to remain the same. Gut feeling.
So what if?
Gut feeling. Gut. Yeah. Well, if 4 didn't work, more than likely you go up. More than likely you go up. Yes.
So. Wait, come back, 'cause I forgot my question.
I'm going on to the next example.
Well, that's where I'm at, so. Yeah.
Okay. All right, guys. Here's where your life could get really hard. Depending on how much you like to write. Which is none across the board for everybody. None across the board for most, I think most everybody in here. Here's the thing. Well, I'm talking about just Gansky doesn't like writing math, I'm sure as well. If you're getting really good, which you should have been by this point in time in chapter 4, if you're getting really good at synthetic division, I'm going to show you not a shortcut, but a shorthand. Okay? If you're not good at synthetic, you're just going to have to do the full thing, which can really suck for you. Okay. Now, the next example is determine between which consecutive integers the real zeros of the given function are located. Determine between. So what I'm saying is, we know how to find rational roots, but what if the roots are irrational? Like square root 6 could be a root and we'll never find it. But we could find if it's between 0 and, or sorry, between 1 and 2. No, between 2 and 3. Square root of 6 is between 2 and 3, so we could have found that the root exists between 2 and 3, even if we can't find exactly what root it is. So determine between which consecutive integers the real zeros of the given function are located. So I've given you lots of room just in case you have to personally do lots of synthetic division. If you're okay with the shorthand, if you've got the synthetic process down in your head, then you can do this shorthand method. Now, guys, if I were to talk about a function, this is a thought bubble off to the side. This is not necessarily, this is the concept behind what's going on. Because when I do synthetic division, not only am I finding factors, what is the other thing synthetic division could be used for way back from section 1 or 2? Somebody raise their hand and tell me. Lucas? Substitution. Absolutely. Synthetic division also acts as finding what do you get when you actually substitute a number into a function. So this is the thought pattern. Don't write this down. Let's say I plug a number into my function and I get that answer. I don't know what number that is, right? Everybody good so far? Then I plug another number down the line in, okay, and I get here. All right? This output value is what? Give me the most simple way you could describe what is negative. This output value is negative. This output value is positive. If this is a function, what's happening between those two dots? It will have to cross the x-axis. The x-axis goes on forever in both directions. There's no way I can get from this point to this point without crossing that x-axis and remaining a function. All right, you guys can, every smart aleck response you might have will either make it not a function. No, that's the only thing. If I want to connect these two dots, right, you guys are like, mrr. No, the x-axis goes on forever. Okay, don't be dumb. If you guys are like, step function, yeah, you know, no, that's not a function anymore, okay? You don't longer have it. So, yeah, discontinuity removes it as being a continuous function. So, true. Anyhow, I'm going to have a 0 because I have to cross the x-axis between a negative and a positive. So I can do rapid, massive amounts of synthetic substitution to get that. So first of all, I'm doing synthetic division. I'm doing it 8 times. Don't know. I do know that the first number always drops. Right? No matter what. First number drops, yeah. First number drops. That number is not wrong. So I don't know. So now let's go ahead and pick some values, right? Gonna go on a little bit. Okay. Now, up to how many zeros could this function have? 3. Same as its power. Now it all depends on your guys' skill at synthetic division. Multiply, add, multiply, add, multiply, add. I don't know that one. 57. I removed, like the drop down, I removed that a little bit. Multiply, add, multiply, add, multiply, add. Which is why I gave lots of room if you need to literally do a synthetic division for each of these numbers. Amaya, how you feeling?
I understand it. I just don't like it.
Are you talking about the math or are you talking about your feelings towards Aiden? Aiden. You understand them, you just don't like them. Yeah. Yeah. Okay. Now, I'm stopped here for a reason. The concept I talked about, that Aaron talked about a second ago, just happened. I crossed from a negative to a positive. Which means I have a 0 between -2 and -1. When I plugged in -2, I got -12. But when I plugged in -1, I got +5. So somewhere between -2 and -1, I crossed the x-axis. Don't know what number, but somewhere between. Keep going. Net multiply. Huh? Sure. 1 times -4. Sorry. So I dropped the 1, right? I'm sorry. 0 times 1 is 0, plus -4 is -4. 0 times -4 is 0, plus -2 is -2. 0 times -2 is -2. I mean 0, sorry. Plus 8 is 8. 0 times -2 is 0, plus 8 is 8. No, because I'm multiplying by 0 every time. All right. Okay. So here, 1 times 1 is 1, plus -4 is -3. 1 times -3 is -3, plus -2 is -5. 1 times -5 is -5, plus 8 is 3. 2 times 1 is 2. Plus negative 4 is negative 2. 2 times negative 2 is negative 4. Plus negative 2 is negative 6. 2 times negative 6 is negative 12. Plus 8. Negative 4, I found a change in sign. Yes, ma'am. Yeah. Well, it gets worse than this, too. Well, in the past, it gets worse / not worse. I think I... Oh. 1 and 2. Okay, I'm going to keep going. 3 makes negative 1. Negative 3, negative 5, negative 15, negative 7. I got to keep going. Why? Because there have to be 3. There have to be 3 zeros. It could have been 1. Because there are 3 roots. And since I've already found 2 of them, like they could have ended up being imaginary zeros, but then I would have only found 1. Okay? There's the last one. Because it actually equals 0. If it equals 0, it's the 0.
So I have to do that until I get 3 zeros.
Not every time. So there are a couple of little rules of thumb that we need to make sure we understand. All right, Destiny? Because we have to be careful, because there could have only been 1 0 in this. It's an odd function, odd positive, right? Which means that it starts low, ends high, which means I've got to cross the x-axis at least once. But I might have done this, in which case that would still be the only 0. So how do I know whether or not I've got to find 3 or just the 1? That's the question, right? So,
You just do every single number.
no. If you're going like right here, like let's say you started at the higher numbers and we're working your way down. Okay? You got negative 4, then it went to 3. You're like, oh, then 8, then it went down to 5, then it went down to negative 12, then it jumped down to negative 49. Once you start getting really big outputs, you could be like, it's going down forever now. If I try negative 4, it's going to be negative ginormous numbers. So I don't need to keep going after that point. When you're coming up, I hit 0 right here, but let's say I hadn't found these other 2, right? And let's say then I hit like 3, and then it's suddenly like 18, and then it's 64. Okay, I'm done. I'm done. It's just getting gigantic. It means you're allergic to nuts. If you eat anything and it starts making your mouth itchy, it means you're allergic.
Okay, wait, so the change in sign, what does that mean?
That means I crossed. I crossed the x-axis, because here I'm negative, here I'm positive. In order to go from a negative to positive, I had to cross 0 at some point.
Technically, we found 3.
I did. We found all 3 on this one. Right. We just happened to find an exact one. Anthony?
Even if it's an exponent of 3, it doesn't mean there's 3.
Doesn't guarantee it.
That's a good indicator.
It's your max. Your exponent, your highest exponent is your maximum number of zeros. Okay. Now in the past, here's how brutal I was. Destiny talks about like, oh my gosh, this would take me forever. In the past, I said, find between what 2 numbers the 0 is located to the nearest 10th. So what you would do at that point, I know I have a 0 between negative 2 and negative 1. I would do this. Figure it out. Figure it out. Figure it out. And you do the same thing. If my sign changed from, right, because right here it changed from negative to positive, I'm finding, did my sign change from negative to positive between these two, or between these two, or between, and if you're lucky, you got it in your first couple. Like you could do a little bit of guessing to like try to narrow it down. It happened between -2 and -1, right? Did it happen closer to -1 or did it happen closer to -2? Happened closer to -1. Because at -1, I'm 5, which is closer to 0 than -12 is. It was brutal. I used to, which means this, you guys are the first year. I'm not going to make do that. I don't. If you need, do you need to go to the front office and like make a phone call to mom or anything? Well, I don't want you to go to anaphylactic shock and your tongue swells so much that.
We can finally use it. Yes. Even though they're worth like $1,000 each.
Sarah?
He's like, she's dramatic, Mr. Big, she's fine. Oh, sorry.
Okay. Was that the last example before the year turn? Okay. Okay. Okay, guys, so I didn't change my directions. I didn't change my directions on 4 and 5. All right, you guys are just going to approximate the real zeros to the nearest whole number. Whole number. 4 and 5 are to the nearest whole number, no longer to the 10th. Yeah. So here, my 0 is closest to -1.
Even if you were making it to the nearest tenth, could we still do it that way?
Yeah. It's just tedious.
No, I mean, could we still
Yeah.
do it that way? We can still do the short term.
Oh, yeah, yeah. Yeah. It's use a calculator, and it's because the thing is this method. If you guys for calculus next year, this method is completely outdated and unnecessary. Okay, and for for state testing, this method is never brought up. To the nearest tenth is never used. So when are you going to need that? I just don't see a point to it. So. Yeah. No, I was just meaner last year. All right, we're done. 11 minutes. You guys can get working.